have a question about 1 through 10?
Number 9.
All right, let's look at number 9. This is in section E1. Number 9 says x is negative, and I'm supposed to describe and graph it. X is negative. So let's look at the number line. Here's 0 on the number line. What does it mean to be negative? X is less than 0. So it says describe and graph. A possible description would be x is less than 0. Or x is less than 0. Does that make sense to everybody if you're negative? Now what would that look like on the number line? It's going to be all this shaded in and an open circle at 0. We wouldn't want to include 0 because 0 is not negative. Just the numbers to the left of 0. All right, anybody else 1 through 10? All right, where did we leave off yesterday on our note sheets?
We're just getting 3.
So we're ready for part 3. Okay, now this connects directly to what we talked about yesterday. I think we can do this. Write as an inequality. Now remember that the parentheses mean open dots. So we're going to draw our number line. We have a 4 and a 6, open dots, shaded in between, right? Everybody good? Now, I want to write that as an inequality. That means I need to write it using less than or greater than symbols. So do you have a thought on that? What would that look like in terms of less thans and greater thans?
4 is less than or greater than x, and x is less than or greater than 6.
Yeah. We always, when we write these inequalities and we're describing an interval, please only use less thans, never greater thans, always less thans. You have a 4 and you have a 6, and you want x to be in between there. So 4 is less than x is less than 6. How about this one? This one's a little trickier. We talked about it yesterday. Again, let's look at it first on the number line. What does this bracket tell me? It's a closed dot at 6. Now wait, they really only gave me one number. Here they gave me 2. Here I really only have one number, because infinity, I guess, is kind of a number, but not a plottable number. So I got my 6 here with a nice closed dot. Now what does this tell me to do? I'm going to infinity, so that's what I have. Right? Now what would that be in terms of an inequality? Now you're not going to write it exactly like this because you don't have 2 numbers. You don't have a start and an end. What numbers are you talking about here? All the x's that are what?
Equal and greater to.
Equal that, so greater than or equal to 6. So x is greater than or equal to 6. That's your inequality. C already has the picture drawn, so you're going to write an inequality just like this one. Because look at the picture in 3C. Don't you have a starting point and an ending point? Okay, so here we go. How are we going to write that interval? What's that going to look like in terms of an inequality? -1 is less than x, less than or equal to 5. Just for practice, if we wrote that as an interval, using this kind of notation, we would have a parentheses at -1, bracket at 5. Very, very good. Now that's exactly what we're doing in part 4. right? So what would that look like in 4A?
Parentheses 4, 9 in parentheses.
Perfect. How about the next one? Bracket, negative 3, 6, and parentheses? Uh-oh. All right, here's one of the tricky ones. Bracket 2, infinity, parentheses, perfect. Now, some of you have got this down pat. Is everybody keeping up okay? All right, now number 5. This is new stuff. All that stuff we talked about yesterday. All right, number 5 is new. What's the additive inverse? Well, first of all, does anybody have an idea?
What if you switch the sign?
You switch the sign. Another word for additive inverse is opposite. So if I say, what's the additive inverse? I'm gonna do B first because it's easier. What's the additive inverse of 16? Negative 16. Now, A is a little bit harder. Can you figure out? What's the additive inverse, or the opposite? What's the opposite of negative 3 plus pi? 3 minus pi. You got to change the sign on the 3, or the negative 3. Change the sign on that, and change the sign on pi. Everybody okay with that? Going 2 examples of that. You all right? Use the distributive property. I bet you're pretty good with the distributive property. Anybody want to venture A? 12x squared plus 6xy. Does everybody understand where the 12 came from? 3 times 4. X times x. See that? X times x, but x squared. And then our 6xy. Well, wait a minute. B doesn't even have any parentheses in it. How can we use the distributive property there? You go backwards. You pull out. The distributive property works both ways. It works by getting rid of the parentheses, which is what we did in example 1, and it works by putting in parentheses, which is what we're going to do here. So what can we pull out of B? Is just an x. Nothing else comes out, just an x. And what would that leave me with in the parentheses if I took out the x? 5x minus 8y. Kids, the distributive property works both ways. Get rid of parentheses, put in parentheses. Do I have 2 B's apparently. All right, so what's the next B? What am I going to do? I can take out an a squared and a z. So I'm taking out the biggest amount of each letter that I can. What am I left with? A plus z to the 4th. Everybody on board? All right, D. Let me distribute it now, so that will be 10.
X to the 3rd minus 6x squared.
Okay, not too bad. How about E? Let me take a 32 out. Does 32 go into 160?
Yeah.
How many times?
5.
So I'll have 5.
A minus B.
And Perfectly fine. And one more. Ooh, be careful on this one. You know what I'm going to warn you about, right?
Yep.
When we distribute, what do we have to be careful to do? The sign. Pay attention, you're distributing a negative. So we're going to have negative 6x
Plus 21.
plus 21y. Part 6 is done. Anybody have an issue with the distributive law? Okay, now look at number 7. Exponents. Now I know that you have learned your rules of exponents. You learned them freshman year and you learned them last year. But what I want you, and they're not changing. The laws of exponents are the laws of exponents. So if you remember them, that's great. But what I want to emphasize here is you can use your logic. How many x's are on the top? 3. How many x's are on the bottom? 2. Who has more?
3.
The top. How many more? 1. So when you reduce this, you're going to have one little x left on top. Because this is xxx, this is xx. When you start canceling, you've got one extra one on the top. Now what about the y's? You have 4 on the top, 5 on the bottom. That means you have 1 extra on the bottom. There's your answer. Now that was nice and easy. B is tricky. Does anybody remember anything about negative exponents? Negative exponents move things around inside the fraction. If you have a negative on the whole fraction, it's simply going to turn the fraction over. So this is automatically going to become this. The negative on the fraction. Now that negative is not just on the 3, it's not just on the x and the y, it's on the whole fraction. So when you have a negative on the whole fraction, it flips the fraction over. Now, what happens to that exponent? Well, now it's positive, and now it goes to everything. So that's going to be x squared, y squared, and 9. Don't forget, the exponent goes to the 3 also. We okay? Oh my. Oh my. Any ideas how to start?
Square the 4x squared.
Take care of this parentheses right here. You're exactly right, Mr. Vaughn. You're going to take care of that parentheses. Now, when you say square that, you mean square everything in there. So that's going to become 16. Now be careful, this is x squared squared. So that'll be x to the 4th. Good job. You're not done.
You can take out the 4x squared.
We can cancel, first of all, 4 goes into 16, right?
4.
Now,
2.
who has more x's? The top? How many more? 2? So we're going to have x squared on the top, and y to the 5th on the top, so I really don't have anything on the bottom, do I? Let's get rid of it. If you like putting it over 1, if you like to have a 1 there in the denominator, that's absolutely fine. Oh boy. Remember what you told me a minute ago. Anything that has a negative exponent gets moved. Now, if the whole fraction has a negative exponent, then everything gets moved. This went to the top, this came to the bottom. That's not what's happening here. Individual items have negative exponents. Okay? So we're going to move those things. This guy right here is going to come to the bottom. But now wait a minute. I'm bringing down 2 x's, but there's already 4 down there. So if I already have 4 in the denominator, and I bring down these 2 more, I'm going to have x to the 6th. There were 4 down here already. These 2 are coming down, giving me a total of 6. Now this is a little trickier. This guy's coming down, but this guy's going up. Do you see that? That's too much for me to process at once, so I'm going to write that down and I'll simplify those in a minute. Here, nothing's negative. Don't move anything. What's the exponent here? 1. So I have 1 z on the top, 6 z's on the bottom. What do I have? 5 z's. Where are they? On the bottom. Now we aren't done. What's wrong? We have y's that need to be reduced. So I have 5 of them on the top and 3 of them on the bottom. That's going to leave me with 2 on the top. There's our answer. Now, here's the question you're asking yourself right now. Other than, when does the bell ring so I get out of here? The question you're asking yourself is, could I do that on my own? Because when we do this, on a quiz, you have to do it by yourself. So, is there a question in there about something we've done so far? Oh, well, there are a couple more. Let's get these done. Not too hard. What's on top? X to the 6th. Now again, if you remember your properties of exponents, when you raise a power to a power, you multiply. But if you forget the properties, it's okay. This means x squared 3 times. So write it out. If you have x squared 3 times, how many x's do you have there? 6. Count them up. 1, 2, 3, 4, 5, 6. What about the bottom? Do not put 3 and do not put 9. It's 3 to the 3rd, which is 27. Very good. And one more. What's that negative do? Flips the whole fraction. So we're going to have x over 2 squared. X squared over 4. You are awesome. Okay, we got to get through a little bit more here. Keep rolling. 8. Write in scientific notation. Now, have you all had chemistry? So you've done scientific notation.
Yeah.
Okay, so you ought to be able to do this. What number would that be in scientific notation? Where's the decimal have to be? Right behind the 3. So we're gonna, here's where it is in the original. We need to move it to here. So we're gonna go 1, 2, 3, 4, 5. So 3.14683 times 10 to the 5th.
Can you use e to the 5th?
Uh-huh. Calculator notation.
Yeah.
Now, sometimes that exponent's positive and sometimes it's negative. Again, we have rules about whether you're moving the decimal point left or right and all that stuff. Use your common sense. If the number's big, its exponent's going to be positive. If the number's little, its exponent's going to be negative. It's very simple. Speaking of which, we have a little number, 7136, 0.7136. That's a little number. So we're expecting a negative exponent. Where should the decimal be? Not in front of the 7, but behind it. So we're going to move it 1 decimal place, 7.136 times 10 to the negative first. Now, part 9 is more scientific notation, but it has some other stuff going on in it. So, this is where our calculator is going to come in handy. But before I go to my calculator, I want to take care of the 10 part. See that negative exponent right there? What do I do with negative exponents? They go to the bottom. So this is going to come down, and I'm going to have 10 to the 8th down here. Well, what about this guy? He's going to the top, and he's going to be 10 to the 6th.
We have 10 to the negative 10 on ours, not negative 6.
Oh, I probably wrote it wrong. I did. So that'd be 10 to the 10 up there. Thank you.
You're welcome.
Now, how many 10s do I have on the top? 15? Everybody see 15?
Yeah.
5 and 10? So there's 15 on the top, and how many on the bottom? 8. Who has more? The top. How many more? 7. So I have 10 to the 7. Now, the 10s are done. Now I'm going to take out my trusty calculator, and what am I going to do with the 3.16 and the 1.43? So 3.16 times 1.43, I have 4.5188. Now what am I going to do with this guy? So divided by 1.23, and I get 3.6738. I'm going to round that off because there's a bunch of stuff there. So, moral of the story, we did it in 2 parts. We took care of all the 10s, and then we took care of the other numbers. Multiplied these 2 and divided that one on my calculator. I didn't waste time working it out by hand. Yes, ma'am?
So don't really get like when it's like negative and you
Okay. And actually, you do get it because you just said it. That's the rule. If something has a negative exponent, if it's in the top of the fraction, it goes to the bottom. If it's already in the bottom, it goes to the top. So when you deal with any negative exponent, the very first thing you should do is make it positive. And you're going to make it positive by moving it within the fraction. Well, if it's in the bottom, it goes to the top. So this went to the top because it was in the bottom. This went to the bottom because it was in the top. So Yep, you switch it. Anytime you have a negative exponent, you're going to switch it. Wherever it is, it goes the other place. Now, we need to do B because it has a tricky component to it. If those of you that are working ahead probably already know what it is. Now we're going to do this the same way. Please take care of the pieces individually. So how many 10s do we have? 23. Everybody okay with that? Now, 3.85 times 4.96. I got 19.096.
Make it 24 and take one away.
Okay, Moses, you're right on target. There is something wrong with this answer. Now, we didn't make any mistakes, I don't think. I typed in what I think. But what's wrong with it? The decimal's not in the right spot. This is the way it came out, and that's okay. But like Moses said, it's not the final answer. To get the final answer, we have to move the decimal point over to here. So we have 1.9096. Now, I changed this number from a 19 to a 1.9. So I made this number smaller. That means that my exponent has to get bigger to keep it balanced. If you're going to make this half smaller, then this half has to get bigger. I only took it up one place because I only moved the decimal one place. If I'd had to move the decimal 2 places, then this would have gone up by 2. Tricky.
If you moved in the opposite direction, would it go down?
Yes, because if, let's say we did it and it came out to be 0.903 times 10 to the 5th. That is not acceptable, so you would have to turn it into 9.03. This time, you went from 0.9 to 9.0, so your number got bigger, which means your exponent would have to get smaller to keep everything. All right, and last thing, remember we have 8 minutes left, I hope? Yeah. Okay, the last thing is part 10. These are properties. Oh my goodness gracious. We gotta know these. On Monday, we'll practice them some more because I have a feeling if you're like all the kids that have come before you, you've forgotten some of your properties. Well, let's see if you can remember any of them. A through H. Anybody see any of them? Wait, raise your hand if you see one you know. Zach Bond.
A distributed.
A is distributed. Let's write it down. That is distributed. He is right on target. A is distributed. Good. All right, so we got 1 out of 8. 12%. Connor?
F is an identity.
F is an identity. It's the multiplicative identity. Very good, Connor. Number, which one was that? F?
Yeah.
Is multiplicative identity. The multiplicative identity says if you multiply by 1, you get the identical thing back again. Very good. All right, another one. Julius.
Is a D with 0 properties?
D is actually the additive identity. When you add 0, you get the same thing back again. So, timesing by 1 and adding 0 are the identity properties. Multiplicative identities, timesing by 1, additive identities, adding 0. Nicely done. Okay, we're doing a good job. Anybody see anything else that maybe you Moses.
E is commutative, I don't know, or associative.
Which one, Moses?
Associative.
It's associative. E is associative. Now, we need to be able to tell those apart, kids. It's the associative property of addition. Notice that when I abbreviate associative, I put an OC on the end because we don't want any bad words floating around in math land. Associative property says that we simply regroup. Everything stays in the same order, but we regroup. Oh, E is associated with multiplication. I'm sorry. I am so sorry. I don't know why I thought addition. E is multiplication. We're multiplying. So 6 times 4 times 3 is the same as 6 times 4 times 3. Notice the numbers are in the same order. Here we grouped these two, here we grouped these two. That's associative.
So then A is commutative.
He's got his hand up, so I'm
Oh, sorry.
That's what I was gonna say.
Which one?
B is commutative.
B is commutative. Because in B, what changed? Not the grouping. What changed was the order. So B is commutative of addition. That one I got right. B is the commutative property of addition. So commutative is order. Associative is grouping. Let me say that again. Commutative is order. If your order is changing, you're commutative. If your grouping is changing, you're associative. Okay, what's left? What's going on in C? Commutative. Commutative of multiplication. C is commutative of multiplication. On the one side, it's 6 times parentheses. On the other side, it's parentheses times 6. That's commutative of multiplication. What about G? Which one? Which one? Multiplication. G is the multiplicative inverse. You are multiplying, that's why it's multiplicative, and you're canceling, that's why it's inverse. If you're using reciprocals, it's the multiplicative inverse. And what about H? It's distributive. Very good. Remember, we talked about that a little bit ago. When you're doing distributive, you can either put the parentheses in or take the parentheses out. So G or H. H is distributive. Did we get them all? Okay. What was C? C was commutative of multiplication because we have 6 times parentheses and then we have parentheses times 6. So we just switched the order of the 6 and the parentheses. All right, anything else? Okay. I have one more thing to hand out to you.
H, you said distributed, so that's 2.
Uh-huh. Please make sure this goes into your binder. We're not going to memorize all these right away. Don't worry. Just put this in your binder so you have it for reference. This is our vocabulary for the whole year, so don't freak out.
On the time,